Welcome to another exercise for this workbook statistics. This time I'm going to focus on measures of association and in particular on Spearman's rank correlation coefficient. Let's have a look at the exercise. Here we have, you work for a well-known producer of soft drinks and you want to launch a new product. In this context, a preliminary study should be conducted and you ask 5 participants to rank their opinion on the taste and the design of the new product using the following scale. Now we have here a scale based on star assignment or asterisk assignment from very good to very bad. Problem is, while we have the number of stars, we do not necessarily know whether there is a distinct difference between 5 and 4 stars or 4 and 3 stars. So we do not know anything about the distances between these measures. So that's an ordinal measure. So we cannot use Pearson's Brevet-Pearson correlation coefficient. We need to use Spearman's variant. And well, finally we have this data set. And as I already motivated, use a suitable measure of relation or association to quantify the strength and the direction of the relation between the two parts of the rating. Well, that's as I motivated, we need to do Spearman's rank correlation. So how to go about this? Well, first off, we need to translate the rankings into numbers. That's actually the first step I'm going to do. I'm going to transform the data I have into ranks, whereas rank 1 is the best and rank 5 the worst ranking possible or rating. So I'm going to copy my original data set. Then if I transform this, here I have 2 stars with the first one with taste. This translates into a 4 since it's the second worst one. Then we have here for the second participant, he rates this with 5 stars, which is actually the best one you could get. So this is rank 1. We're going to do this similarly. 1 is the worst one here, so he gets a 5, 3 and 2. And then we do the same thing for design, giving us this ranked data set. The advantage at this point, each of our ranks is assigned only once. If this were not the case, we should have used the median, the mean assignment method. That's detailed in a different session. And it also allows us to use the alternative shorter version for Spearman's rank correlation coefficient, which only works if you have each rank assigned only once. So well, we're going to use this table here. Now what we're going to do with this is just calculate Pearson's Brevet-Pearson's correlation coefficient for this ranked data set. So I'm going to copy the table with the ranks. I'm going to add the squared x ranks, which is just all these numbers from the first row to the power of 2. Then I'm going to do the same thing for the design, for the y ranked values, so 5 squared, 2 squared, 4 squared, 1 squared, 3 squared. And finally, I'm going to multiply rank of x and rank of y. So 4 times 5, 1 times 2, 5 times 4, 3 times 1, and 2 times 3. That's actually the 3 rows I need to add, and I need to add 2 additional columns, or actually only 1 additional column, but I'm going to make one intermediate step. I'm going to sum up all the values before. So for each row, I'm going to calculate the row total, and I'm going to divide this by the number of observations, giving me the averages of all of these 5 variables. And that's actually the values I'm going to need if I want to calculate my Spearman's correlation coefficient, or as I said, the Brevet-Pearson variant for this data set. Because if I now take a look at the formula, the classical one is just Pearson correlation applied not to the original values, but to the ranks. So here we have the average of rank x times rank y, that's actually 10.2, minus average of rank x times average of rank y, that's those 2 values. Down here, the standard deviation for rank of x and rank of y. So if I take the values, here I have the 10.2, 3 and 3, those 2. Down here, I have the squared for x, that's the 11 here, minus the average of rank of x, that's this 3 here. And I'm going to do the same thing for y. So I'm taking the average of rank of y squared, that's this 11, minus rank of y averaged and squared, that's this one here, to the power of 2, giving me in the end these values. And as a final result, a Spearman rank correlation coefficient of 0.6. So on the one hand, we see it's a positive relation. Those guys who rate taste good also rate design good. It also is larger than 0.5, so it's a strong relation because the threshold values are 0.1, 0.3 and 0.5. This is definitely larger than 0.5. Larger than 0.5 means strong relation. Well, that's a version to calculate this rank correlation coefficient in either case. So even if you have ranks which are assigned twice, 3 times, 4 times, how often you like, you can still use this version. But since each rank is assigned only once here, we can also use a shortened version. And that's what I'm going to do as alternative 2 on the next slide. So here I have the original table, and I'm just going to add this part. I'm just going to take the difference between those two variables. So 4 minus 5 squared is 1. 1 minus 2 squared is 1. 5 minus 4 squared is 1. 3 minus 1 squared is 2. Is 2 times 2, to the power of 2, is 4. And 2 minus 3 is 1 squared is 1. So this gives me these values. And that's actually everything I need for this alternative, because in the alternative version, I use the sums for this. I have this formula which I can use, and I see here most of the upper part, that's just the sum of this row. So I basically only need the 8 I just calculated here. That's the whole part here. I'm multiplying 6 with 8. The 6 is always fixed. Then I'm going to divide by n times n squared minus 1. So I have 5 observations, so 5 times 25 minus 1. And the result I'm going to subtract from 1. So I have 1 minus 48 by 120. This turns out to be 0.6 as well. Well, this would actually be strange if this wouldn't turn out to be the same result as before. However, well, this is only the case due to the fact that each rank appears only once. If this weren't given, then we would get a significant different result here with alternative 2 than with alternative 1. So that's something to keep in mind. This shortened version only works if you assign each rank only once, or using some more precise terms, if we do not have ties in our dataset. Well, that concludes this exercise, so I hope you enjoyed it. I say goodbye and see you next time.